Today we're going to take a look at the binomial theorem, which will help us tomorrow with some probability. So today is going to seem a little crazy, not related to probability, but we will relate that back tomorrow. So the first thing we're going to take a look at is this Pascal's triangle. And some of you may have seen this before. So the pattern is to get the number below, you add the two numbers above. So 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, and so on. 15 plus 20 is 27, so it always starts with a 1. 1 plus 7 is 8. 7 plus 21 is 29. 21 plus 35 is 56. 35 and 35 is 70. 35 and 21 is 56. 21 and 7 is 28. 8, and then we would have a 1. So why we're going to take a look at this is we're going to look for some patterns here. So what we can do is expand some of these, and rather than do it on our own, I have a calculator here that'll do this. So if we want to expand x plus y to the power of 2, it turns out to be x squared plus 2xy plus y squared. So this is x squared plus 2xy plus y squared. And now let's see, to the power of 3, we have x cubed. So we have x cubed plus 3x squared y plus 3xy squared plus y. And now let's see, to the 4th. X to the 4th plus 4x cubed y. So we have x to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. And we could keep going here, but some of you might notice some patterns here. Our coefficients, 1, 2, 1. This next one, 1, 3, 3, 1. The next one, 1, 4, 6, 4, 1. You'll notice it's our rows in Pascal's triangle. So this row corresponds to the coefficients to the power of 2, power of 3, power of 4. So we call that a row number, but row actually starts with that first integer number. This is kind of considered row 0. Now another place where you will see these Pascal triangle patterns is with combinations. And what a combination is if we had, let's say we had 3 colors. We had green, orange, and red. How could you just pick 2 of these colors? Well, we could pick green and orange, green and red, or orange and red. So a combination that sometimes you'll see as 3C2, you'll sometimes see it as C3, 2, or sometimes you even see it as 3, 2. That's the number of ways, this is our total number of objects, and the number of ways that we can pick this number of items. And what it turns out on your calculator here, we have 3 choosing 2 there. We'll do another one here. Let's see, probability combination. Let's do 5, 1. Whoops. Menu probability combination 5, 1. So 5 choose 1, there's 5 ways. Menu probability combination 5, 2. There's 10 ways. Menu probability combination 5, 3. 5, 10, 10. You'll notice these corresponds to the rows as well. So we had these numbers show up on our next row, 5, 10, 10. So this is 5C0, 5C1, 5C2, 5C3, 5C4, 5C5. So it corresponds to that row number. Now how are we going to use this? When you'll take a look at our next problem here, we're asked to expand this. So we know that we have our row of Pascal's triangle here. You'll also know these exponents. What does x do? It goes 3, 2, 1, and then there aren't any. X is there's 0, or excuse me, y, 0, 1, 2, 3. So as the powers go up, one power goes up, the other power goes down. And you'll notice when we add our power, 2 is 4, 3 and 1 is 4, it always adds up to that power. So if we're to expand this, we know we have to look at the fourth row of Pascal's triangle. So 1, 4, 6, 4, 1. And I tend to write this vertically. So 1, 4, 6, 4, 1. That's our integer. Well, each one's going to have an x. And then each one's going to have that 3. And now it's x starts to the highest power, so 4, 3, 2, 1, 0. And the 3 starts at 0, 1, 2, 3, 4. And now we just have to write this out. These are all added together. So 3 to the 0 is 1, so this is x to the 4th, plus, let's see, 4 times 3, so 12x cubed, plus 6 times 9, 54x squared, plus, what would that be there, 27 times 3 is 9, 27 times 4, 28, carry the 2, 8, 9, 10, 108 x plus 3 to the 4th, which is 81. So here is that expansion. So this next one, what row are we looking at? We're looking at the 5th. So we can go down here and see the 5th. 1, 5, 10, 10, 5, 1. So again, 1, 10, 1, 5, excuse me. 1, 5, 10, 10, 5, 1 times, we're going to have this 2 to the x. And then we have, it's not just a y, it's a negative y. So it's to the 5th. So this starts 5, 4, 3, 2, 1, 0. This one goes 0, 1, 2, 3, 4, 5. So what does this equal? Well, the only tricky part here is we have to make sure we distribute here. So 1 times 2 to the 5th, so that would be 32x to the 5th, because this is just 1. 2 to the 4th, so we have, what's our number in front? 5 times 2 to the 4th, so that would be 80. And I notice that this is a minus y to the 1st, so minus 80x to the 4th y. Our next one, 2 to the 3rd is 8 times 10, so we have 80x cubed y squared. And let's see, this will be a negative because it's minus y cubed, so minus 4 times 10 is 40 x squared y cubed. Then we have 5 times 2 to the 1st, so plus 10x y to the 4th. And then this is 1, so we'd have, this is 5th there, whoops, minus y to the 5th. All right, so one more that we're going to take a look at here. We have to find the third term. So we're looking at row 7. So row 7, 1, 7, 21, 35, 35, 21, 7, and 1. And we're looking for the x cubed term. Well, let's see. This would be to the 7th, to the 6th, to the 5th. This would be 4th. So we're really looking for this one. We're looking for, we have 4x cubed. Then we'd have -1, and if this is 3, it has to add to 7 because it's 0, 1, 2, 3, and 4. So we just have to multiply this one out. So we have 35 times 4 to the power of 3, 2240, x cubed.